Swami, and today we're here to discuss about the concept that is K-means clustering. And what is K-means? K-means it is an unsupervised machine learning algorithm used to group unlabeled data into key clusters based on similarity. Yeah, as we already know that what is unsupervised machine learning means. Yeah, what is unsupervised? Unsupervised means no labeled data. When there is no labels, then we can consider it as unsupervised machine learning. For example, when we have to define a cat or a dog without any label, by providing the image, then we can consider as that is unlabeled ones. And we can identify those based on the patterns. And the goal of this k-means clustering is to cluster contain similar type of data points of this k-means clustering. Yeah, when we have to take this example, before applying the k-means algorithm, how the data points look like, and after applying the k-means data algorithm, how the points to be look like. And these are to be called as clusters. And each cluster have same group of data. And let me go through some a real life example. Imagine a shopping mall and you're the owner of the mall and you have the data of your customers based on their age and spending score. Means that which type of aged people have more spend or less spend on things. Means we have to group based on the teens who spend less and middle-aged people who spend a lot and older people who spend moderately. You want this type of data. But how do you know to collect all these data where? That's why the k-means comes on. And this k-means clustering algorithm can automatically group into k groups, means clusters, based on the similarities between the data. And how this k-means clustering works. And how this it works? We are given a data set of items with certain features and values for those features. And like a vector, how the vector to be like, we have to say give the data of the items which contain features. And the task is to categorize these two items into groups. Means that we have the data and we have to go through with the groups. And those groups will use the k-means algorithm and we can achieve this through this formula of k-means. And k is the name of the algorithm that represents number of groups, clusters we want to classify our items in here. Means here the k means k, the value of the k is 3. That's why here it forms the 3 groups based on the features that they got. And here it is the centroid. X is nothing but the centroid where it is the mean point of that particular cluster. And how the algorithm do. The algorithm will categorize the items into k groups or clusters based on their similarity. And to calculate those similarity, we use the Euclidean distance. Yeah, as we already know that what is the formula for the Euclidean? Euclidean's distance is nothing but which is the distance or straight line distance between 2 points in a space. For example, if P1 is equal to x1, y1 and P2 is equal to x2, y2, then we can consider as the distance of the Euclidean distance is root over x1 minus x2 whole square plus y2 minus y2. Yeah, we will particularly do here. Euclidean distance is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. And this square root will apply the whole. This is the Euclidean distance formula. And we now have to discuss about how the k-means algorithm will actually will work. And the process of working, first we have to randomly initialize k points called means or cluster centroids. As we previously discussed here, what the centroid is, it is the mean of that particular group or a cluster. And we can categorize each item to its closest mean, and we update the mean coordinates, which are the averages of items categorized in that so far. Means that we have to categorize the items to closest its mean, which means for these centroid, which items ought to be similar, which is the nearest points, which is the closest points. Now we have to repeat the same process until all the clusters are to be formed as a groups. And here is the algorithm for the k-means clustering. First, we have to start and we have to initialize the number of clusters that we want and the selection of centroids that is also happening here. And calculation of the distance. Yeah, as we previously mentioned, we use the formula that is square root of x2 minus x1 whole square plus y2 minus y1. These distances are to be known as Euclidean distance. And when we have to calculate that distance, if it is a minimum distance, then the point or the element which is bring to the same cluster. If it is not the closest, it will remain the same. And repeat the process from step 2, and we have to repeat the same process until it completes the features or the elements. Then we can just stop the process. And this is the entire workflow of the k-means clustering. And now we have to check the code of how these k-means clustering will work. Before going with that, it is the collaborate, so we have to connect this. And first, what we have to do is we have to import the certain libraries that we want. First, I import NumPy for numerical operations as we calculating the distance, right? So I just import NumPy. And Matplotlib is basically for visualizing data and clusters. And the sklearn datasets, which is the dataset that it generates a synthetic datasets with clusters for testing. As we are doing this for the testing, how these k-means clustering is actually to be work. That's why I choose this datasets from the sklearn. Let's make blobs. For generates a synthetic dataset with clusters for testing. And the step 2 is to create custom dataset with make blobs and plot it. Now it's time for visualization of how the blobs are looking. And here, n is nothing but the samples. I'll take 500 samples. It generates 500 data points, and n features is equal to 2, which means that each point has two features, that is x and y. And for the centers, that is three clusters, which it is the centroid. It is also being called as centers. And the random state ensures reproducibility, which is the in general we have to use 23. And I initialize this x and y. X is the shape array shape of 500 comma 2, and y is the true cluster labels. That's why I choose these two variables and these uh, things. And now I just want to visualize these things, what exactly that I got. Next, I initialize the variable fig. Then I have to plot the one. And which would be look like. All these features have 500, which of the features 2, x and y. And there are three centers and it states the random space 2. And dot scatter is nothing but it is a scatter plot of what the thing that I do. And grid is true is nothing but I just want to grid how the positioning of the items. PLD dot show means it shows the actual representation or actual visualization of k means clustering area of the data. And now the third step includes initializing the random centroids, the code that initializes these three central clusters for k means clustering. And now for I just initialize k is equal to 3 for to match the blobs. And I use these clusters as a dictionary to store each cluster centroid endpoints Now I take this np.random.seed, which is reproducible random numbers. I don't know. I just want these or this. I take example dataset and now I just want to work on that example dataset to give the example, right? Now, for the center, randomly initialize centroids with a range scaled to the data. Here we can scale that from x dot shape 1 to minus 1, from 2 star to nb dot random shape 1 minus 1, which indicates the generate random points in the range minus 2 to 2, right? And each cluster is the centroid coordinates, is dictionary with centroid coordinates and the list of data points. And yeah, here is the cell run 3. Just we initialize the random centroids for this step. And now our step 4 is to visualize the initial center or centroids with the data points. And now the centroids, how the centroids ought to be look like, which is the random centroids. Um, I just want to scatter plot, which means I plotting this using the scatter plot, and I just want a grid. And if for I in clusters, now I just iterating through the clusters that we initialized here, and center is equal to clusters of I of center, which means that the center at the center of the positions, I just it generates the scatter plots of what the thing that I have to do, which of the color red and marked as a star. If I give this asterisk, that's why I got this type of asterisk, which is indicates the center. This is what step 5. Now we have to find the formula. We have to find the distance. As we already know the formula, that is Euclidean distance. What Euclidean distance? Square root of x2 minus x1 whole square plus y2 minus y1 whole square, which is a predefined one in numpys. That's why I use np dot sqrt, np dot sum p1 minus p2 whole square, where p1 and p2 are the points and sqrt is a method, and which is np, it is a numpy by itself. And then step 6, now we have creating the function and assign update the cluster center. And this is the main step that assigns data points to the nearest cluster center, and the m steps updates cluster centers based on the means of assigned points in the k-means cluster. Yeah. Now what should the things that are going to do is it's loop through each index of data point, and np.argmin, which is finds the index of the closest center, choose the closest center, and we have to assign those points to the list, these points to the list, and returns the clusters direct dictionary. And now in the step 7, we are creating the function to predict the cluster for the range data points. Now what the thing that it is do is we're just creating the function that for each cluster compute the mean of its assigned points, update the center to its mean, and clear the points to be split over the next iteration. If no data points are to be assigned, then it shows 0. And in step 8, predict the clusters of the data points. And now in the step 9, we can go into assign, update, and predicting the cluster. And now we can show that here is the clusters that we got for the input. And this is all about the k-means clustering. And this is the full code, and this is the collab link that I can share. Thank you.